and then you take which the greater number on the right, the smaller number on the left. So if it's a right tail test, do this and 1 minus this. This happens to be 0.05, but it works the opposite. The 0.95s are the smaller one, the 0.05s are the larger one because it's area to the right. And if you get confused, do 1 minus this as well. And take the lesser of the two for the left one, take the greater of the two for the right one. Did that seem to work okay for everybody?
Yes.
Good. Just getting through this is going to be long enough. Again, a right tail test, degrees of freedom. Make sure you're looking up degrees of freedom. And it's kind of like a nice table because it says DF on the side, degrees of freedom.
Wait, I just looked up 0.05.
Yes. Yes, you will, because it's area to the right. Now, if this was a z-score, 0.05 would be here, but you would have had to look up 0.95. Now, it works opposite. It's the area to the right on the chi-square. So the smaller number of the area is on the right, but that's the larger of the chi-square cutoffs. So what I'm saying is if you get confused, look up the pair and then place it. If it's the smaller number, it's going to go on the left because these go from 0 to infinity.
Okay.
The larger number is going to go on the right. And the right-hand test is not the problem. It's the left-hand test. That's the problem. Because it's area to the right. Your z-score is different. So like, for instance, here's a left-tail test with area 0.01. If you look up 0.01, you're going to get this number over here. Because it wants the area to the right. It wants this whole area. It wants you to do the 1 minus. So when in doubt, do them both. It's right across the same line in the table. On your degrees of freedom, go across the same line, right across the same line. One is going to be smaller than the other. This we call your chi-square critical value. This cutoff value, they use sub-0, I use sub-C. And again, degrees of freedom, if your degrees of freedom is not there, go to the one above it. Same as table 5. A two-tail, the only thing with two-tailed is it has to share. So divide this guy by 2. Then do the 1 minus. And then get both. The smaller one on the left, the larger one on the right. Good? And lastly, they just gave you basically so that you would see this is where you fail to reject H0. This is where you reject H0 and you fail to reject H0. Remember, all these are like a family of curves that are slightly skewed. They're all skewed to the right. And it's like a family of curves, hence your degrees of freedom. So they're just all a little bit skewed to the right. So your areas are always equal to one under the curve, but not really equal like when you trace them. But if you're giving me a sketch, I'm fine with whatever you did. So see where they fall and make a decision. This is your decision. Am I failing to reject HO? Am I rejecting HO? The decision, the interpretation is exactly the same. So are we okay with this?
For the two-tail, you do both sides.
Both sides. But you got to divide it in half first. Both sides. Okay? All right. Yes. So we say sigma is less than 1.4. So what's the HO? Or equal to 1.4. So what tail test do we have? A left tail test. Remember, these work a little bit differently. We have a left tail test. There's no negatives here. It goes from 0 to infinity. That's why I usually put the little bar here too. It kind of helps you remember. Like this is the end. This is the 0 part. So we need to find a critical value. So let's pull out the sample information. a random sample of 25 calls come in, so what's the degrees of freedom? 24, and has a sample standard deviation of 1.1 minutes at a level of significance of 0.10. Is there enough evidence? Da-da-da. And our population is normally distributed. In this one, they're going to have to tell you this. So, how do we look this up to find a critical value? Table 6, and what am I looking up? Okay, so I want to look up this, and I want to look up the 90. With my degrees of freedom 24, just put a piece of paper straight across it. If you look up the 10, you're going to get the right-hand side one. This one needs the 90, so that you don't think about it, look up both. Take the lesser of the two. I'm on the left-hand side. So take the lesser of the two. What do you get? 15.659. Thank you. Everybody get this? Okay? Good, thank you. So now, we test. So we have to use the chi-square test that we used before. So we say n-1, there's your degrees of freedom, over the sample standard deviation squared and the population standard deviation squared. I just have to pay attention. If I'm given a variance, I plug it in for S2, S squared, or sigma squared. If I'm given a standard deviation, I'm going to have to square it. So I take my degrees of freedom, and I multiply it by my standard deviation squared over my population standard deviation squared. And this will give you your test statistic. So if you take a look at the book, it's in the book 398. They do it, and they get 14.816. This is my test statistic. So now all I have to do is remember, say this is reject H0, this is fail to reject H0. And I want to see, where does this fall? Does it fall to the left in my shaded area or to the right in my unshaded area? Shaded. So what's my decision? Good. Reject H0. Now, if I reject H0, I'm actually liking what they said. So I go to my chart, I claim it's HA, I reject H0. I use these words, there's enough evidence at a level of significance of 0.10 to support the claim that the standard deviation of the length of times it takes for incoming phone calls to be transferred to the correct office is less than 1.4 minutes. Yeah, I'll give you a formula sheet. You know the formula sheet that I gave you? It has the table right on it. That formula packet, you'll get on the test as well. So that's what I'm saying. If you, as you go through your review, if you find something that, you know, that is not there, put it there just so that you remember to study from it. And let me know too, because maybe it should belong there. Questions? Pretty straightforward, right? Okay. You guys do try at 5. I want it the same exact way. Same exact way. Alright, so my claim. A police chief claims that the standard deviation of in the lengths of response times is less than 3.7 minutes. So Michael, what's my claim?
The claim is that the population standard deviation is less than 3.7 minutes.
Okay, so how am I going to write that?
Sigma less than sign 3.7.
Good. HO or HA?
HA.
And what confirms that it's an HA?
It's not equal to.
It's not equal to, but what word later on? What ties it in? Support. So we look down here and we say, is there enough evidence to support his claim? We know that we have to be HA. Every once in a while, they don't use a support or a reject. They'll say, you know, something else, but most of the time, 95% of the time, support or reject. So what's the HO? Good. So what tail test do we have? Left tail test. So we're looking for your critical value. This is your reject HO. This is your fail to reject HO. So Julia, what'd you get for a critical value? 2.733. Everybody get 2.733? Everybody can find it? Good. Yeah, and this is another case. This is the case where you might want to do the 1 minus this and look to see which one is less. Do the two tails at the same time, because this is the area to the right we need to look up in this one. So just do them both at the same time. Okay, pull out your sample information. We have a random sample of how many? 9. A sample standard deviation, that's your S. Okay, so therefore, find your test statistic. What's your degrees of freedom? 8. Your sample standard deviation, square it. What's your population standard deviation? Good. And what's your test statistic? 5.125. So, where do we fall? Fail to reject what? HO. Good. Fail to reject, you gotta say HO. Because you could reject HA, but we're always testing the HO. So if we fail to reject this, are we gonna be able to support his claim? No. So follow your chart. Your claim is your HA. You failed to reject your HO. There is not enough evidence at a level of significance of 0.05 to support the police chief's claim that the standard deviation in the lengths of response times is less than 3.7 minutes. Good? That's what I want to hear.
Which one's the one that you know if it has squared or not?
The other word would say variance. If you saw the word variance, then it would say this, squared. And then when you put that in, you don't need to square it. Yeah. Good point. Did everybody catch what Mercedes just brought up? If they use the word variance, that's where you're just going to plug it in and then not square it. Okay, let's try one.
If, like, you're already subtracting the 1 minus, like, the 0.05, and you
Yes.
you look at the graph, at 5, and is it always going to go right?
Yes, because your area on your chi-square is area to the right. So this is the problem. On your z-score, you look this up. This was 0.05 because it's the area to the left. On your chi-square, here's the problem. This is really this area to the right. So rather than not confuse you which one you're doing, just do both of them. And see the one that's less, put it on the left, greater than put it on the right. The chi-square is the only one that does area to the right. Like everybody else, T, Z, area to the left. Yeah, I don't know why they did it different, but somewhere along the line, it's different. All right, let's do 1 2-tail test together, guys. Ready? Good. Yeah, just to make sure it's low. Okay, a sports good manufacturer claims that the variance of the strength of a certain fishing line is 15.9. So now let's just make sure when we look down here, do we have enough evidence to reject the manufacturer's claim? What should our claim be, HO or HA? HO. Are we getting an HO? Because it says what? Is. Good. What symbol do I use to represent population variance? Sigma or squared? Good. This is my claim. Good. This is my HO. My HA tells me what is my tail? 2 tail. So remember, there's no negatives in here. So you're going to find a tail here, excuse me, and a tail here. So this is your reject H0, and fail to reject H0. I want to see the H0 on this. Some of you guys are still forgetting to put the H0 in here. Makes a difference. How do I find the critical values for this guy? My level of significance is 0.05. I'm using a sample, and I've got a sample of 15 and a sample variance of 21.8. How am I going to find my cutoff values? Table, divide by 2. I'm going to share this first. So this is going to come out to be 0.025, and what's its other part? If I subtract it from 1, I need two values, 0.975. Good. 0.975. So find me those two values. Yes. Yes. Come up with one. 5.629 and 119.
Yes.
9. Thank you. Thank you.
You put 5.2. 5.629.
Oh, all right. Well, this lesson for a math teacher. Yes, I am. Thank you. Thank you. All right, so those are our cutoff values. Now what do I need to do? Do the test statistic. That's what's left. What's your degrees of freedom? 14, that's your n minus 1. What goes on top, your sample or your population? Sample, good. Should I square it? No, it's already squared. And my population on the bottom. It's already squared. Variance is your standard deviation squared. So 19.195. And what's my decision? Fail to reject H0. Good. Well, smack in the middle, not in the middle, but over here somewhere. Fail to reject H0. That's my decision. Go back to your chart. My claim is my HO. I failed to reject HO, so there's not enough evidence at a level of significance of 0.05, give me the original 0.05, to reject the manufacturer's claim that the variance of the strength of a certain fishing line is 15.9. Good? It's as simple as that. The chi-square is a little bit weirder to look at. It doesn't fall like with your table 4, like for area to the left, area to the right. But really, it's not that different once we get that part over with. And what I also find, it's a little bit more difficult because the numbers go from 0 to infinity. There's no negative sign here. So because there's no symmetry, you can't take 1 and make it negative like we do for your with your table 4 or table 5. So everybody's okay with this part? All right, you ready to do some from the book?